Let us now see the fourth one. Fourth one is for the complementation of unary operation. This complementation. For this unary operation, complementation. For each and every member of this set B, we shall have an element that is called the complement of this element. Complement of this element, here we have considered A, and the complement of A we have denoted by this A complement. When we shall call that this is the complement of A, when these two relations will hold good. Number one tells us if we add this complement element with the original element, here as we have considered A, so A plus A complement, this must be equal to the multiplicative identity element. Carefully note this. This is the multiplicative identity element. We have considered the addition of this element with the complement element, and this will be equal to the multiplicative identity element. And the second property is if we multiply them, that means A, here A into A complement, we shall have the additive identity element. I don't think you should keep it in your remembrance very carefully, because in case of addition you are getting multiplicative identity element, and in case of multiplication you are getting this additive identity element. Be careful about this very. If these four axioms, number one the commutativity, number two is the distributive property, number three is the existence of identity element, and number four is the existence of the complement element for each element. These four axioms are called Huntington's postulates. And if these four postulates are satisfied for any non-empty set together with two binary operations, as here we have defined as addition and multiplication, and also for the one unary operation, here as we have defined this complementation by complementation sign, then that non-empty set will be called a Boolean algebra with respect to these two binary operations and one unary operation. Usually it is denoted by a fixed tuple B plus dot complementation and the additive identity and the multiplicative identity. You may also write this as in this form, B plus dot complementation, omitting these two identity elements. It can also be written. Okay. Here we have considered addition as a binary operation and multiplication as a binary operation. This is a general question whether to define a Boolean algebra we are restricted or bounded to consider specifically these two binary operations, addition and multiplications, or not. Whether, and obviously not bounded or restricted to multiplication merely. We may also consider any other form. Sometimes you may also find that the union of two sets and the intersection of those two sets in place of addition and multiplication respectively. That means in place of addition we may use this sign union, and in place of multiplication we may use this intersection for these 6 tuples or this 4 tuples. This will form a Boolean algebra if all these 4 postulates with respect to these two binary operations and the unary operation is the same, complementation, be satisfied. We may also use these two logical operators. This is join operator and this is meet operator. Sometimes this is called OR and this is called AND. And if these 4 postulates of Huntington is satisfied, according to Huntington are satisfied, then this non-empty set will form a Boolean algebra with respect to this binary operation, and the unary operation is complementation. Okay. In our next video, we shall continue from here and we shall illustrate this definition considering an example. Okay. Thank you.